A research student was investigating the relationship between job satisfaction and productivity. Data from 12 employees is given on the table and a scatter plot of the data is shown. Okay, so we have you hate your job up to you love your job, and then this is you're a bad worker and you're a good worker. So, not too surprisingly, people who hate their jobs don't work well, and people who like their jobs more also work better. My first impression of this was that a square root function would fit it kind of nice because it has this sharp rise at the beginning and then flattens out later on. But they say that it could be expressed as a linear function instead. So, okay, we can do that. We're going to assume that there's a straight line fit in here. And let's see. There we are. We're going to try to find a line that goes through the middle of those points. It's not going to hit every one of them, obviously, but it should get close. And there should be roughly half the points below the line and roughly half the points above. So let's see if we can make that happen. They say, perform a linear regression on the data and determine a relationship in the form P equals AJ plus B. In other words, Y equals MX plus B. They're just using different letters to correspond to productivity and job satisfaction. So, out come the regression machines. Stat, edit. If you've got old data in your calculator, you can go up to the list title and hit clear, enter, and it blows up the whole list. It saves you having to get rid of entries one at a time. Clear, enter. Okay, so we have job satisfactions 3, 8, 7, 5, 9, 6, 6, 10, 8, 2, 5, 7. And the productivities that go with them are 44, 81, 75, 66, 90, 70, 71, 98, 75, 25, 68, and 77. The lists are the same length, so I don't think I forgot anything. I'm just going to double check these. 25, 75, 98, 71, 70, 90, 66, 75, 81, 44. I think we're probably good. All right, so we've still got a stat plot on from a previous example, so that's nice. If you didn't, you would turn it on now by going enter on and then exiting out. And for a window, let's see, satisfactions go up to 10, so 0 to 12 isn't so bad there. I'll scale it every one. And productivity seems like it might be a percentage. We have one person who's at 98, so I'll go up to like 120 just to give us a little space. And, oops, okay, so there's our scatter plot. This, I apologize, is data from a previous example, which I will get rid of. Okay, we have a scatter plot. It looks like theirs. That's encouraging. Now, they want a linear regression on this data. So, regressions are a stat thing. You go back into the stat menu, over to calc, and linear regression is the very first kind. You say enter. It uses list 1 and list 2 automatically, so you don't have to change anything. You just say enter. It thinks for a moment and comes up with, I'm just writing this down before I get rid of the calculator, 7.91x plus 19.89. Okay, so according to our regression, productivity is 7.91 times job satisfaction rating plus 1989. Another student looked at the scatter plot and suggested the relation could be represented by a cubic function with a point of inflection. Yeah, maybe. You could have a shape that goes cubic like that, flattens out. The trouble is it's going to want to rise very sharply at the end. But, I don't know, maybe people who are deliriously happy at their jobs do have insane productivity. We'll see. they want us to try that too. So now with this same data, do a cubic regression and see what it suggests. So stat, calc, cubic regression, there it is. Again, we're using list 1 and 2, so we don't have to tweak anything. It has to think longer here because it's solving for 4 parameters instead of just 2. And it comes up with 0.32x cubed minus 6.37x squared plus 45.90x minus 44, what is that? 42.21. Okay, let's get those graphed, and then we'll see which one looks better. 7.91x plus 1989. And for the cubic, 0.32x cubed minus 6.37x squared plus 45.9x minus 44.21. Okay, the straight line, not bad. The cubic, that's actually pretty good. So the cubic is saying that if you take an employee from really hating their job to only disliking their job, you actually get a major increase in their productivity. People who slightly dislike their job or slightly like their job, there's kind of a plateau where not much changes. And then the cubic says that if people go from liking their job to loving it, then they get way better. The linear function says if you go from liking to loving your job, yeah, you improve, but not a ton. I admit, within this range, or within this domain, the cubic is actually a pretty good fit. My hesitation came from what happens if you go a little further out. Here you can see the linear fits this really well, and the cubic starts to spike up really rapidly, which I thought would be unrealistic. But if these numbers are percentages, so that they can never go higher than 100, and if job satisfaction peaks at 10, so if this is the only range we're looking at, then in that area, the cubic's actually very good. It represents this flattening out effect better than the linear does. So I didn't think I would like the cubic, but I'm going to hedge just a little and say for job satisfactions that are between 0 and 10, the region that we're talking about, the cubic fits slightly better. It represents that flat area in the middle of the stat plot better than the linear equation did.